So welcome to evaluating trig functions. We're going to finish up today. You have plenty of time. All right, so we talked about our fluency practice, and so 30 degrees is pi over 6, and 60 degrees is pi over 3. It's going to become very evident today why we needed to learn this part, okay? 3, 2, 1. All right, so let's look at the 45. So all you base with the 45 is easy, right? You just have to remember that it's pi over 4, all the way around. All right, so we're going to use all of that today. Yesterday we learned about the special triangles, right? We found out that, I already wrote it, we found out that the shorter leg is 1, the hypotenuse is twice as much, and the longer leg is root 3. We had Jocelyn in 5th period that said, since each of these angles, let's go to my other screen for this. So she said that since each of these angles is different, 30, 60, it has 3 different angles. It has 3 different angles. She said that's how she remembers that this one has the root 3. So some of you might get these two mixed up, but you just have to remember which one's bigger if you turn them both into a square root. To turn this one into a square root, it would be root 4. Root 4 equals 2, and root 4 is larger than root 3. So if you ever ask yourself, that's the way to check. All right, moving on to our second special triangle. Our second special triangle has 2 angles, 45 and 40, that are the same, and that's how we can remember that it's root 2. Somebody said, well, why is that one root 2? Well, if we change everything into square roots, the square root of 1 is 1, the square root of 1 is 1, the square root of 2 is bigger than the square root of 1. Okay, is that clear? All right. So now we're going to use both of them today. Both. So we're going to go to our good friend Sohcahtoa from geometry. Please hold your applause. All right. Yeah, you like my picture? It's the corner cat. He's one a cute kitty. You guys are so critical. Okay. All right. Fine. No, you guys are much better. Like much better screen. Right? Why does Mrs. Muller go through all the time to put up little silly pictures? Because this is so much more interesting to look at. Right? More appealing to the eye. Wait. Fidel said that was a catastrophe. Okay. Much better. Right? Alright, 5, 4, 3, 2, 1. Alright, so we're going to talk about why all of these things, why we have, okay guys, you got to calm down. When I was teaching geometry, I went through all of trig, and then right before the test, somebody raised their hand, boldly raised their hand, and bravely said, what's Sohcahtoa? And I was like, we just did a whole unit of trig, and you don't know what Sohcahtoa is? It just told me that I didn't explain it very well. Like, right? So I want to make sure everybody understands what Sohcahtoa is. It's an acronym. It's a way to remember the sine, cosine, and tangent ratios. Okay? So the sine ratio is opposite over hypotenuse. That's why it's so. Get it? So, opposite over hypotenuse. Cosine is adjacent over hypotenuse. tangent is toa. Opposite over adjacent. Now let's talk about opposite over adjacent. The next confusion comes from what angle are we talking about? We're always talking about the angle that's touching the pole, I should say. Right? The polar axis, yes, but just the pole. If it was a coordinate plane, we call it the origin. We're always talking about the angle that is touching the origin. Alright, so if I'm looking at that angle right there, and I want to know what's opposite that angle, that side is opposite of it. It's not touching it. The hypotenuse is easy. It's the one that's always slanted. It's the longest one. The adjacent one. Give me a real-world example for adjacent. Me and my brother, because we're that close. Our rooms are adjacent, right? Our doors are adjacent. They're right next to each other. Adjacent. I live adjacent to the railroad tracks, right? So this angle is touching the adjacent side. So that would be adjacent. Are we good so far? Alrighty. So I'm going to go ahead. Did it save? This should be the opposite. Okay. Well, give me a second here. Let me erase all this. Spoiler alert. Pausing. Alright, so let's use them before we get to our units. Why are we guys still talking? Okay, so before we start looking at the unit circle, let's just look at this from what it is right now. So sine of 45. Sine is opposite over hypotenuse. Okay? So if I look at this triangle, right, this 45-degree triangle, what's opposite? 1. What's hypotenuse? Root 2. Let's look at cosine. Cosine of 45 degrees. Okay, so cosine is adjacent over hypotenuse. Adjacent is 1. Hypotenuse is root 2. Tangent is opposite over adjacent. So my opposite is my 1, and my adjacent is also 1. Okay, I'm going to come back to this one, okay, for a special reason. All right, let's use it with our unit circle. First thing I need to do is my first step here is draw an angle. So I'm going to draw 30 degrees. Doesn't matter whether it's sine or cosine or tangent, I'm just going to draw 30 degrees. Let's see how close I can get. I'm going to say that's 30 degrees. There's my 30-degree angle. Which one of those triangles, if they were pieces of a puzzle, would fit into there? Middle one. I didn't do very good. Let's just say that's my triangle, okay? All right, what is this, what we learned, right, with special triangles, what's the smaller leg? Yes, it is the opposite, it is the smaller one. What is it, what's its value? 1. And the hypotenuse? Root 3. Okay, everybody with me so far? Alright, sine, so I've drawn my angle, I found my reference angle, I chose my special triangle, now I'm going to find my trig ratio. I'm using sine. Sine is so, or opposite over hypotenuse. Opposite of this angle right here, I should move it over so you can see it better. So you can see it, there we go. So opposite of this angle right here, opposite of this angle is 1. Adjacent of this angle is root 3. So the answer to this is 1 over root 3. Oh, hypotenuse, I'm sorry. Thank you. Thank you, thank you, thank you. Hypotenuse, 2. 1 over 2. The last, okay, we don't need any writing over here. We're just paying attention. The last thing I need to consider is plus and minuses. This is my positive side of my graph. This is my negative side of my graph. This is my positive direction, and this is my negative direction. Okay, we're going to use that. So this is positive, and this one right here is positive, correct? It's going up. This one, they're both positive. We don't worry about the two. It doesn't have anything to do with it. It's kind of like slope, but I'll tell you that in a second. All right. You'll see. Why do we have such a fixed mindset?
You're trying to train your brain in that. Do you see this green?
Yes, exactly. You're going to see exactly why. Oh, gee, hold on. Hold on. No, I would never. Okay, Fidel, I'll tell you right now, even anywhere from 7th grade all the way to calculus, I would never use that formula.
That word.
Okay.
But it may take some extra time and effort.
Okay. So the first thing I'm going to do is I'm going to draw my angle, right? Draw my angle. Where is 120? Second quadrant, 30 in right there. So which one of those triangles am I going to use? The third one, right? I'm not going to move the triangles anymore. I'm just going to leave them right there. Even though this one, actually underneath it, has one. Oh, it doesn't. I erased it. Shoot. It was one that was turned the opposite way. At this point, I'm just going to show you guys how to draw it, because this confused the other class, and I learned my lesson. So what happens, I'm just going to draw this triangle. Again. I'm going to draw this triangle, and this is how you draw the triangles. Okay, okay, let's start over. All right. This is how you draw the triangle. Having a hard time. Okay, so I told you that the triangles always start from the pole, right? Then you have to draw the leg straight down to the x-axis. So if I'm on this side, I would go down, correct? If I was here, I would go up. If I was over here, I would go up, right? You got to go back up to the x-axis. So on this one, I'm going to go down. So what degree is this? That's a 60 degree. Okay, so we're good. So does that look good? All right, so here's my angle. So I've drawn my angle. I found the reference angle. My reference angle is 60, right? So I'm going to I chose my special triangle. Now I need to find my trig ratio. Cosine is cos, which is adjacent over hypotenuse. So this side is what? 1 or negative 1, correct? It's going left on the x-axis, so it's negative 1. This side is root 3, and it's positive because it's going up, and this side is 2. So what's my adjacent to this angle? Negative 1. And what's my hypotenuse? So if I were to evaluate cosine of 120 degrees, I would say that was negative 1/2. Yes. Unless it's 1 over 1. All right, let's try another one. You guys ready for one, or you want to see one more? Let me show you this one. This tangent of 3 pi over 4. Immediately, some bell should be ringing in your head. (45). Pi over 4 or 45. You should be saying that's a 45-degree angle. Somewhere on this, it's a 45-degree angle, right? If okay, so 3/4 of a pi is less than a whole pi. So it has to be in either the first or second because it's less than a pi. So it's in the second quadrant, right? Now let's just count it. If I had a fourth of a pi, 2/4 of a pi, 3/4 of a pi. So I've drawn my reference angle, right? Or I've drawn my angle. I already know the reference because that's what I was referring to. It's 45. My special triangle is going to be the 45, 45, 45. So it's going to be 1, 1, and √2. So I draw this, and it's 1, -1, 1, √2. Tangent is TOA. Opposite over adjacent. What's the opposite to this angle? 1. What's the adjacent to this angle? -1. So this is -1. Now you ready for one?
Yes.
Let's see how many more I have. Okay, 3 more. I kind of want to let you in on a little secret. Maybe let's have you guys do one and then I'll let you in on my little secret. Okay, you guys try this one on your own. Yes, sir? Okay, so sine of 225. 225. You automatically say? That wasn't a good reenaction. 45. Okay. And I'm going to say, immediately I would say to you, 0, 1, 2, 3. It must be in this quadrant. Anybody understand why? 45, 35, 25, 15. Right? Right? Okay. So it's over here. 225. 225 looks like this. I know it's this triangle here that's a 1, 1, √2. So that means even though it's kind of flipped upside down, right, it's a 1, 1, √2. Very important though, it's negative and negative. So I drew my angle, found my reference angle. Robert's going to stop drawing on the board. Choose special triangle. We did. Find trig ratio. Trig ratio, sine. So, sine is so. Opposite over hypotenuse equals, my opposite of this angle is -1. My hypotenuse of this angle is √2. I was thinking TOA, Madison. Sorry. So, oh, sorry. It's also, oh, it's not negative because my hypotenuse is never negative. Okay. So if I evaluate this trig function, it's -1 over √2. Okay, do you want to see my little... Okay, for those of you that don't understand the Sohcahtoa, I've got another way to look at it. You ready? Let's go back to this one. Okay, guys. Do you guys see that sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse? They're both over hypotenuse, right? I would argue that that sine is your y, and cosine is your x. Everybody see the relationship there? Adjacent is on the x-axis. Opposite is on the y-axis. Always. Always. So if you see sine, you're going to think y. If you see cosine, you're going to think x. Tangent is opposite over adjacent. If opposite is my sine, right, which is the same as slope. Change in y over change in x. Yep. Right? Change in y, so that's when you said something about slope, I'm like, yes, because tangent is slope, y over x. I want to show you a different way to do that, because you'll love it. And it'll totally help you later in college. In fact, I'll do it after this. Okay, guys, so let's use our new understanding of Sohcahtoa. I'm going to do the next one. I need quiet, guys. I'm going to do the next one with that understanding. Sign. So what am I thinking to myself? I'm thinking why, right? Because sign is always the opposite, right? This is always the opposite, and then on this one it's also opposite. Do you guys see that that's always going up and down? Always. Guys, you need to stop talking. I don't care about y equals mx plus c right now, okay? So this one is my adjacent. It's always my adjacent, right? Isn't it always flat with the x-axis? So that's the way to look at it. All right, so I have 11 pi over 6. You should immediately think pi over 6 or 30 degrees. 30 degrees, it's almost all the way around the circle, so it's going to be right here. So there's my triangle. So that's obviously a 30-degree triangle. My 30-degree triangle is 1, 2, root 3. So this is going to be -1. The x-axis, that's the y-axis, is -1. The x-axis is positive root 3, and my hypotenuse is 2. Sine is y, so we're going to have -1 over 2. Because both sine and cosine are both over the hypotenuse, right? Okay, if that confuses you, we'll do it the old-fashioned way. So, opposite over hypotenuse. My opposite of this angle is -1. Sorry, -1. And my hypotenuse is 2. Same answer, once I fix my negative. What? This one. Yeah. Okay, I'm going to try, you guys want to try one? Try that one. Okay, so cosine of 330. Immediately I am saying to myself x. Okay, or I'm going to put it here because that looks like x times cosine. X. 330 is all the way over here. Right? I just did this one. Right? The same triangle. So this is 1, -1. This is root 3, and this is 2. This time I'm talking about the x-axis, so it's going to be root 3 over 2. One, 2, root 3. Smallest side, hypotenuse, longer leg. That's what we learned yesterday. This is a 30-degree angle. So I look at my 30 and I say the shorter leg of the 30. The shorter leg is 1. The longer leg is root 3, and the hypotenuse is 2. That's where I'm coming up with those numbers. One more? I don't think let's get to the worksheet, because you guys are way too talkative.